Hello again. We've got 8.4, multiplying polynomials. This is the last part in Unit 8. So yeah, we're going to do everything multiplying here. We did adding and subtracting. Now we're looking at multiplying. So there's different ways to think about this. Generally, what you need to remember is when you multiply, you always times the coefficients and add the exponents. Okay, so times the coefficients, add the exponents. Remember that little bit there. Okay. So if we look at this first one, yes, these are monomials. We've got 7 times 9, which you guys have done before a billion times back when you were in elementary school, and so this is 63. Again, we just had all we had was our coefficients there, our constants, and so we just had to multiply that. No exponents in that case. Here we've got two monomials. We've got x to the second, x to the seventh. The coefficients are 1. So 1 times 1 is just going to give you 1. And so we've got to add the exponents when we're multiplying. So 2 plus 7 is 9. So we're going to have x to the 9th on that one. This next example, we've got 3x to the 5th times 4. So again, add your constants or multiply your constants or coefficients, add your exponents. The second term has no exponents, so all I'm going to do is take 4 and times it to 3, because those are my two whole numbers. So that'll give me 12. And then I have x to the 5th. That doesn't change because there's no exponent over here. So in adding and subtracting, we had to make sure they were like terms to be able to add or subtract. Multiplying, you can multiply non-like terms. And then this is where you see this most often. Again, our coefficients 3 and 6. 3 times 6 is 18. We multiply our coefficients. And then our exponents we're going to add. We've got 3 and 5. We add that. That gives us 8. And we get a monomial that becomes 18x to the 8th. Let's look at a couple more here. Now we've got a monomial to a polynomial. This is just distributing. So we've got 8. And whenever there's nothing in between them, that's timesing. When they're touching that parenthesis, it's timesing. And it's timesing to x to the 3rd minus 4x. So we're just going to multiply the 8 to the x to the 3rd, and then the 8 to the 4x. You might have seen this like this. They usually distribute this. They take 8 times x to the 3rd. Well, 8 times x to the 3rd is just 8x to the 3rd, because it's 8 times 1, which is 8. And then you've probably seen this where it multiplies the second time. It's like a nice little rainbow or whatever you want to think of. It's making it rain or something. So we go 8 times 4x. So 8 and 4 can multiply because those are our coefficients. So we go negative 32 because that's what 8 times negative 4 is. And then I leave my x there, and my exponent doesn't change because there's nothing to add to it. So again, multiply your coefficients, add your exponents. Okay, this is a good example, the second one here. So I've got 4x to the second that's going to multiply to 3x to the 3rd, and 6x to the 2nd, and negative 2x, and 5. So I'm just going to distribute this in, multiply my coefficients. So 4 and 3 multiply together to give me 12. And then I add my exponents. 2 and 3 give me 5. Then I do the same thing because I've got to multiply this 4x squared to everything. I multiply my coefficients, so 4 and 6 multiply together to give me positive 24. And then I add my exponents. I have x squared, 2 plus 2 is 4. So that gives me x to the 4th. Got to do this again. 4x squared minus 2x, so I'm going to multiply the 4 and the negative 2, which will give me negative 8. And then I'm going to have x to the, I've got 2, and then remember, there's really a 1 right here. And so 2 plus 1 is 3. And then the last one, I'm going to multiply to my constant. So I just multiply 5 to 4, which gives me positive 20. And then my x squared stays the same. And that becomes my new polynomial. All right, getting more complicated again. Same idea, multiply coefficients, add exponents. So in this case, we've got a binomial to a binomial. You may have heard this little term called FOIL. You're just multiplying the first terms. That's what the F stands for. Outside terms, that's what the O stands for. Inside terms, that's what the I. And then L represents last terms. If that helps you, that's great. If not, don't worry about it. We're really just going to take one term in one of the binomials. So I'm going to take this X, and I'm going to multiply it to both terms in the second one. So I'm going to go X times X, which is X to the first, X to the first. So I add my exponents. That gives me X squared. Then I'm going to go X times negative 4. Well, X times negative 4 just gives me negative 4X. Okay, so I'm going to take one term and multiply it to both terms in the other. Then I have to take my other term that I haven't multiplied and multiply that to the other as well. Right, so I'm going to go 3 times x, which gives me positive 3x, and then 3 times negative 4, which gives me negative 12. The only trick with these ones is we're not done because we need to combine like terms. We have to combine anything that's like, because now we have a bunch of addition and subtraction, which we did in the previous two units or concepts. So x squared is not like anything. Negative 4x is like 3x, so I can combine those. So I leave my x squared. I can combine negative 4x plus 3x. I just add my coefficients. So negative 4 plus 3 is negative 1x. And then the negative 12 is not like anything, so I just leave the negative 12 as is. So we get x squared minus x minus 12. Right? So again, take one, distribute it to both, take the other and distribute it to both, or think of FOIL, whichever is easiest. I like the lines here. It looks like a little crab hand. So crab hand it. All right, next one here, we're going to do the same thing. We're going to take 7x to the third, and we're going to multiply it to x squared, which will give me 7x to the fifth because I add my exponents. Then I'm going to take 7x to the third and multiply it to 9. In this case, I multiply 7 and 9 together because those are my coefficients. So I'm going to get 63x to the third. Again, my x to the third doesn't change because there's no exponents here. Then I'm going to take the negative 3x and multiply it to x squared, which that'll give me negative 3x to the, remember this is 1 there, x to the third, because I add my exponents. Then I'm going to take negative 3x times 9, which is going to give me negative 27, because negative 3 times 9 is negative 27. Then I leave my x. Then the last thing to do is just check, make sure if there is any like terms, you need to combine those. Look at my 5x to the fifth. There's no x to the fifth there, so that stays. Look at 63x to the third. There is a negative 3x to the third. So these middle two terms are like. So I'm just going to subtract these. So I've got 63 minus 3, which gives me positive 60. And I leave my x to the third. Don't change that. And then negative 27x, there are no like terms with that. So I just rewrite that down here as negative 27x. And that's it for binomial to binomial. So if you've noticed the previous two slides, I've just taken whatever's there and distributed it to everything in the other. In this case, I had 2. I've got to multiply that to each of those to each one. We can keep going forever and ever. If we have a binomial to a trinomial, still just going to take one of my terms here and multiply that. So I'm going to multiply this over to each term. So this gets really long in the sense it's not necessarily any more difficult. It's just more. So 3x times 2x to the third gives me 6x to the fourth. Then I go 3x times negative 5x, which is going to give me negative 15x to the second. And then I'm going to go 3x times 2, which is going to give me positive 6x. Then I do the same thing here. I've got to take my negative 1 and multiply it to everything as well. And so I've got -1 times 2x to the third, which will give me -2x to the third. Got -1 times -5x, and -1 times -5 gives me +5. And I leave my x, and then -1 times 2, which gives me -2. And then we just make sure we can't, if we've got any like terms. So is there any x to the fourth terms? No, so I leave that 6x to the fourth. Is there any x to the third? I look for that. There is an x to the third here. Again, I'm going to write this in standard form as I go. Next one is squared terms. Is there any squared terms? Yep, right here, the -15. Then I look for x to the first. There is a 6x and a 5x. I'm going to add those. So 6 plus 5 is 11. So I go plus 11x. And then I look at my constant. There's no other constant, so I just relieve my -2. And that becomes my new polynomial. Kind of a long process, right? This, again, I just draw the lines because it helps me keep everything organized. And this looks like a crab hand as well. Three-dimensional crab hand nonetheless. So I could keep doing this. Again, a trinomial to a trinomial, it's the same idea. I'm just going to take one term in one, and I'm going to multiply that to each term. Again, it gets very long and lengthy, but we'll do this. So I get 3x to the fourth. I get -2x to the third, and then I get -2x squared. Then I'm going to take my 5x and multiply that to everything. So I get -5x times 3x squared, which will give me -15x to the third. -5x times -2x, which gives me +10x squared. And then -5x times -2, which gives me +10x. Then the last thing, I got to multiply my 4 to everything. So 4 times 3 is 12x squared. 4 times -2 is -8x. And then 4 times -2 gives me -8. And I combine any like terms. So my highest power is x to the fourth. There is only one of those, so I just drop that down. And I look at my x to the thirds. There's 2 of those. So -2 minus 15 gives me -17 x to the third. And that takes care of those 3 terms. I've got 3 x to the squared terms. So I've got -2 plus 10 plus 12. So -2 plus 10 gives me 8, and then 8 plus 12 gives me 20. So this would be plus 20x squared. That takes care of those 3 terms. Then I look for x terms. I've got 10x and -8x. I can subtract those. So 10 minus 8 gives me a +2x. Takes care of those. And then I just have my -8. And that can't finish that. Last question here, it says, is are polynomials closed under multiplication? Absolutely, yes, they are. I get a polynomial every time I multiply. We're not going to do any more of these, but we could do a trinomial to a 4-term, 5-term. It just gets really redundant. It's the same idea. You just take one term and distribute it, however many you have. So on this one we had 2, multiplied it to each 3 of those. So thank the heavens above we don't have to do this very often because it's long. It's long. It's not difficult, just long. So. All right, this has been your math moment with Mummy.